uh, now we are going to start uh, that we already started the vector part. Just we are going to continue that portion, and we are just going to introduce the concept of today. Now we are going to introduce a concept of the unit vector. Just how can I apply the concept of the unit vector whenever I am analyzing some vector concept, vector applications, vector numericals. So we are going to introduce the unit vector. So what is just like unit vector is? How can I understand what is unit vector? Just like see, I'm going to tell that force. I'm telling that a 10 Newton force acting along east. A 10 Newton force acting along east in the direction of the east. So uh, so how just can I just get a unit vector in that direction? So what to do? What is the magnitude of the force? 10 Newton. So 10 Newton force divided by magnitude of that force. What is the magnitude? 10, na? And the force is 10 Newton along the east. So 10 by 10, what should be, why? What is the thing is going to come? 1 Newton. So 1 Newton, that force which is going to act along east, that is my unit vector, unit force which is going to act in the direction of the east. So the concept of the vector, unit vector, is that the vector divided by the magnitude of the vector. Simple thing, the vector divided by the magnitude of the vector, this is called unit vector. Suppose I'm going to have a vector A. We are going to write like this way, vector A, isn't it? Just have to take an arrow sign, bar sign, and what is it? How just we can represent the unit vector? Just in the this kind of shape. So this is this is a mod, the mod of that vector. So just like the vector divided by mod of the vector. So unit vector is a vector divided by mod of that vector is called unit vector. Unit vector is represented as a cap, like a cap sign. It is not a bar sign, it is a cap sign. So vector by mod of the vector is a unit vector. This is called unit vector. Unit vector along A. Simple thing, right? Okay, no problem. Check. Okay, just like see, some known unit vectors are there, some branded, some informed, previously informed unit vectors are we know. Just like see, suppose a vector which is going to act along x-axis, we term it as I cap. I cap is a just known branded unit vector, which always we know that whenever I'm just going to put I cap, we have to know that it is a unit vector along x-axis. If I'm just going to tell that y-axis, so this is the unit vector is j cap. And if I'm just going to take a three-dimensional z-axis, this is the unit vector is k cap. Okay. So I cap, j cap, k cap, in this three way we can represent any vector by three-dimensionally. Just like see in the two-dimensional option, suppose this is my x-axis, this is my y-axis. Okay. This is x-axis, y-axis. I'm just going to have, I want to represent a vector like this way. This is a vector. It is a vector, is a directed line segment. So how can I represent that vector? Suppose I can have a component along x-axis like this way. This one is a component. This one is a component. So this component is along x-axis. This component is along y-axis. Okay. So now see, suppose this length is 1, 2, 3, 4, 5, 6, 7. So this up to this point is a length is 7. So in a vector term, so how can I represent as a vector? 7 I cap, because one unit is a unit vector, I cap in the x-axis, that we know, and multiplied by 7. So this will be the vector. Okay. And this one, the y-axis, 1, 2, 3, 4. So how can I represent 4 j cap? So 7 I cap plus 4 j cap is a total vector. If the vector is r, we can write the r like this way: 7 I cap plus 4 j cap. Simple thing. I think you understand, children. Huh? 7 I cap plus 4j cap is the actual vector. Just addition of these two vectors, I'm going to have this a vector like this, isn't it? Okay, no problem. So now see, similarly, just I can have it any vector like vector, suppose r dashed. Okay, the vector r dashed. This length is a, this length is b. So r dashed vector can be represented a, this is x axis, the y axis, this is the a I cap plus b j cap plus, simple thing. Understanding my point? Okay, no problem. Acha. Now, now suppose for this r vector, I want to find unit vector along r. So what is the concept? Unit vector, vector by mod of the vector. This is called r cap. This is called r cap. R cap is what? R cap is unit vector. Unit vector along the r. So you can see that, children, how can I find the magnitude of the r? It is root over of 7 square plus 4 square, isn't it? You can see this length is 7, this length is 4. So 7 square plus 4 square whole root, I will get this thing, isn't it? So I can write the r cap can be represented 7I cap plus 4j cap divided by root over of 7 square plus 4 square. This is the r cap, the unit vector which is going to exist along r. I think, children, you understand the concept, you understand. Similarly, how can I represent r dashed cap? R dashed, how can I represent r dashed cap? Mane unit vector along r dashed. So we can write like this way: vector r dashed divided by mod of vector r dashed. Okay. So a I cap plus b j cap divided by, what is the mod of the r? This r dashed. What is the mod? Root over a square plus b square. Root over of a square plus b square. So this is the unit vector. We can tell the r dashed cap. This is the unit vector along r dashed. I think, children, you understand what I'm telling. You are able to understand, isn't it? Similarly, you can see that if I'm just going to add these two vector, suppose r1 x1 I cap plus y1 j cap. Similarly, r2 vector, I can write x2 I cap plus y2 j cap. Then this is the first vector, this is the second vector. So if I want to write r1 plus r2, the two vectors, just like, see, the component of r1 along x-axis, the length, the magnitude is x1. Component of r2 is in the x-axis is x2, isn't it? So both these two components is along x-axis. That simply they are going to just get added. Two components, vector components definitely, which are going to act along the x-axis, same direction. So they has to be added. So similarly, so I'm just going to add x1 plus x2 I cap plus. Why addition is possible? Because two vectors in the same direction. Just we have just explained previously. Whenever the two vectors in parallel or in the same direction, just simply we just simply add the what kind of addition? Simply magnitude addition. Yes, you can see x1 plus x2. Just simply adding x1 plus x2. Similarly, here y1 plus y2 j cap. So the vector r1 plus r2 is going to become like this way. Okay, understanding, children? A simple thing. It is a very simple thing. So if I just resolve the vector into the vector components in the x-axis, y-axis, and then now we're going to come the three-dimensional z-axis, then it is easier to add or easier to subtract also. If I want to do some vector operation dividing into the components, it is easier to do some operation on the vectors. Okay, very good. Now see, just like uh, if I am going to have the just of what I was going to discuss, the third component, the vector component, third what z-axis component, z component. Okay, let us see. Just let's start that portion. If I'm just going to think that. The x-axis, the y-axis, the z-axis. Okay, and this is a vector. This is a vector. You can see it's a cuboid type of structure. Cuboid. I'm going to have this length A, this length B, and this vertical length C. Okay, A, B, C. So if it is going to have the cuboid, cuboid is having a length A, breadth B, and height is C. Check. Now, in the x-axis, what is the component? A I cap. This along the y-axis, this is a B, Bj cap, and along the z-axis, Ck cap. Because unit vector along the z-axis is k cap. So let's see k cap. If I just going to add these three, I am going to get a vector r. This is the vector r. This is a combination of the combining the components a I cap, j cap, k cap. I'm going to have the total resultant vector. Is it? It's clear, isn't it? Okay, fine. I have a I cap plus b j cap plus c k cap. Now let us see that magnitude of the r. Let us think. Just the magnitude of the r is r. Simple thing. Vector r have magnitude r. Now, actually speaking, if I just going to take this magnitude, what should be? This is a cuboid, and the magnitude is the diagonal of that cuboid, na? Isn't it? Diagonal. So how can I find the diagonal? Root over of a square plus b square plus c square. Just we have just done this kind of formulas in the mensuration in the class 9-10, isn't it? So what should be the value of the magnitude of the r? That is going to become a square plus b square plus c square, isn't it? So now, if anyone is going to tell that, so what should be the unit vector along the vector r? So unit vector r cap, the vector r divided by the mod of r. Vector r divided by the mod of r. So vector r is that a I cap plus b j cap plus c k cap divided by magnitude is equal to root over of a square plus b square plus c square. This is the r cap here. Okay, children, understanding my point? So vector by mod of the vector, this is the unit vector, and the unit vector is the r cap here. We can have like this way. Okay, so therefore the vector are existing. Now you can see that the component of the r which is going to exist along the x-axis, this length is a. Let us think this angle. Simply the vector r going to make some angle with the x-axis, isn't it? So let us think that the angle vector r is making with the this x-axis is alpha. Okay, let us think this angle that vector is going to make a angle with the y-axis beta, and it is going to make with the angle gamma with the z-axis. Tale vector r making with the x-axis that alpha angle, vector r making with beta angle with the y-axis and gamma angle with the z-axis. Simple thing. So what should be the component of the r along the x? R cos alpha, isn't it? R cos alpha, nothing else. That should be equal to a. Similarly, b r cos beta, isn't it? Similarly, c is equal to r cos gamma. Simple thing, just like A vector is there, a angle is there, suppose alpha, and we can calculate this length just previously r. This is the, if the angle is there and this length is there, it should be r cos alpha. Same manner I'm going to get this length, this a is equal to r cos alpha. Simple thing, doesn't get confused. Similarly, this is having a projection along this direction, the r cos beta. Similarly, r cos gamma, this length, this length, this length. I think children you are understanding. Okay, so now if I'm just going to square it, a square plus b square plus c square, what I can get from here, r square if I take common, cos square alpha plus cos square beta plus cos square gamma. Okay, this is what? This is what? This is a magnitude. Magnitude already we have taken the r. This is a r magnitude. This is the r magnitude of the vector. Okay, so we can put the r square is equal to r square into cos square alpha plus cos square beta plus cos square gamma. So r square also cancelling out, we are going to get a result cos square alpha plus cos square beta plus cos square gamma. Okay, so this value, the value of the cos square alpha plus cos square beta plus cos square gamma is ultimately we're going to have, it is 1. The value of the cos square alpha plus cos square beta plus cos square gamma, summation of the value of the cos square alpha plus cos square beta plus cos square gamma is equal to 1. So this cos alpha, cos beta, cos gamma, it is called direction cosines. Direction cosines. What it means? What it means? Direction cosine. You can see that. You can see cos, cosine, see, and direction. Because what is the angle this vector is going to make with the x-axis, y-axis, z-axis? The angle is going to determine the direction of this vector, isn't it? That's my direction, and cosine. Since it is cos, that's my cosines. So in this way, we have written this. We have given the name, the direction, but direction cosines. Okay, this cos alpha, cos beta, cos gamma. So addition of the direction cosines of this three-dimensional vector, square of the addition of the directions cosines is equal to 1. I think children, it is clear to you. Everybody understood, isn't it? Any problem? No problem. Very nice. Very good. Okay, you can see that just like if I am going to think about, let us think just like if it is given that like I'm going to have a vector A 2i cap plus 3j cap plus k cap b minus I cap plus k cap minus 4k. Okay, two vectors are there. Okay, question is going to come like this way, that find a vector x, find a vector x, so that if I is going to add with the a and b, if I add with a and b, I'm going to get a vector which is going to exist, along z axis, no, along y axis, and it should be a unit vector. What the question I have told? Just find a vector x. Whenever I'm going to add with the a plus b, I'm going to get a unit vector along y axis. That's the question. Okay. So we have to find the vector x. So this question is that we have to find such a vector. We have to find such a vector so that the addition of this thing is a unit vector along y-axis. So what is the unit vector along y-axis? The j. Simple. The addition this plus this is going to become j. So you can see that x plus, what is the value of the a? It is given 2i cap plus 3j cap plus k cap. Okay. And what is the b? Minus I cap plus j cap minus 4k cap. Okay. Is equal to j. Okay. তাহলে x vector plus 2i cap minus I cap মানে only I cap, 3j cap plus j cap মানে 4j cap, k cap minus 4k cap মানে 3k cap is equal to j cap. Okay, তাহলে x vector plus, okay, I 4j, and here another j is there, so we just can write I plus 3j minus 3k is equal to 0 vector. 0 vector means it's called null vector. Okay. So x plus this vector is equal to 0. So x should be the vector x. It is going to become minus I cap minus 3j cap plus 3k cap. This is the vector x. If I'm just going to add with the a and b, with a plus b, the total result will become a unit vector along y-axis. I think, children, you understood this concept. You have understood this thing, isn't it? Okay, fine. Now, children, like if the question comes like this way, suppose I'm just going to think that a vector a and b, vector a 3i cap plus 4j, okay, and b is equal to I cap plus 5j. Okay, I suppose I have given two vectors. No problem. Now we have to find a vector which is having same magnitude as b, which is having same magnitude as b, but which is parallel to a. I have to find a vector x, okay, which is having same magnitude as b, but which is parallel to a. So how can I get the vector which is parallel to a? So now if I just want to get a parallel vector along the a, I have to, first of all, we have to find the unit vector along a. So what is the unit vector along a? A cap, it should be 3i cap plus 4j cap divided by root over of 3 square plus 4 square. Mane a cap is equal to 3i cap plus 4j cap divided by 5. This is the unit vector along a. Check the unit vector along a. Check. So now if I multiply with some number, it is going to become vector, and that vector will be parallel to the unit vector. If it's a unit vector is multiplied, it should be a parallel to the vector a. It's a simple concept, isn't it? Just suppose I'm just going to have a vector which is parallel to the x-axis. So what is the unit vector? I cap. So if I cap is multiplied with a 10 I cap, it should be this vector 10 I cap, it should be parallel to the x-axis. Simple thing. Similarly, a vector which is parallel to the unit vector, I've got first of all I've got the a vector which is unit vector and which is going to act along the a. It is a unit vector along a. So if I just going to multiply with some number, that vector also is going to become parallel with the a. Simple. Now we have to find a vector x that is going to have the magnitude of b, but it should be a parallel to the a. Okay, so what is the magnitude of b? Tell me, what is the magnitude of b? Magnitude of the b, mod of the b is equal to root over of 1 square plus 5 square. 1 square মানে 1, 5 square 25 মানে root over 26 ঠিক তাহলে the vector which is parallel to the A and having possessing magnitude of the B, that should be mod of AB into A cap. It should be root over 26 into 3I cap plus 4J cap divided by 5. So this is the vector. It is a X. Just we have assumed that this vector is having magnitude of B, but which is parallel to the A. Okay, children, understanding my point? I think you understand. I think you are understanding. Very good. Just now, we are going to apply something here. Just one application to do here. Let us see. This is x-axis. A ball is coming, striking. Ball is having mass m, having a velocity v, and it bounces like this way in the same speed v. Okay, and it is angle is theta. Naturally, it is bouncing and it is making angle same angle theta. Okay. If this thing is going to happen here, if I'm going to think that this direction is x-axis. Okay. So we have to find what is the change of momentum. In this situation is the change of momentum. Mass, it is having mass m, velocity v, so it is having a momentum mv. So if that reflector, this x-axis was not present, it would have traveled in this direction. Naturally, this theta and this theta is same opposite angle, isn't it? So this is the momentum. I'm going to have mv. This component is mv cos theta. Okay. And after that rebound, whenever it is bouncing from the x-axis, this momentum is mv. It is having also the component along this direction, mv cos theta. But before collision, it is having this direction momentum. So it is having a component like this way. This is mv sin theta. And this one, this is the direction, the mv cos theta, and this is also mv sin theta. Okay, so you can see after the bounce from the x-axis, after the bouncing from the x-axis, if I just going to see that I'm just going to observe the x-axis. I'm going to observe the x-axis. Before collision, the momentum, I can write momentum initial. What can I write like this way? It is having a two component, mv cos theta. So we can write like in the mv cos theta I cap. And it is a downward negative this component. So that we can write mv sin theta j cap, isn't it? Any problem? It's a downward. This is a downward. This is a if I'm just going to take that y-axis, the downward. So minus mv sin theta. So my final momentum. How can I write? The x-axis component is same, mv cos theta. mv cos theta I cap, but this component, the y-axis component is to become positive, plus mv sin theta j cap. Okay, so now change of momentum, if I just going to see the change of momentum, final momentum minus initial momentum. Okay, so now this minus this, so what the thing is going to happen? Because you can observe that this mv cos theta I cap, mv cos theta I cap, they are same, so they are going to get cancelled, and mv sin theta j cap minus of minus is a plus, so ultimately it is going to come 2mv sin theta j cap. Therefore the change of momentum, final momentum minus initial momentum, delta p, it is called change of momentum. We can write like this way, 2mv sin theta j cap. Children, I think you're understanding. Okay, I think you understand. Any problem? No problem. If still having a confusion, if you're still having some doubt, you can definitely ask to the our expert groups in our VidyaNest. We will definitely help you we're ready to help you. Okay, so no problem. So try to understand. If you have any confusion, if you have any doubt, you can call to the VidyaNest. Okay, very good. So now it's like, see, uh, so in the previous classes, yes, we have seen that the addition of the vector, we have also seen that the subtraction of the vectors, also we are observing some of the addition and subtraction applications with the I cap j cap. Okay, we are going to have some applications with the I cap j cap, k cap, all are the unit vectors of vector, unit vectors along x axis, y axis and z axis. Okay, now see what we can observe from here. Vector vector operations can be done in addition, vector operations can be done in subtractions, and vector operation of the product also is possible, vector product, vector multiplications of the vector by vector product, just like see dot product, dot product. What is this thing actually? Dot product. What is this? Actually, see, you can observe dot product is a special thing, is a special concept. Whenever I'm just going to just combining two vector, but we are creating some scalar. We are creating some scalar, okay, from vector. Then that concept of the dot product comes. This is the thing we are creating. The how to create, it is a concept, like just like see that. I'm just going to tell the vector A is existing. Suppose ax I cap, ay a cap, az a cap. Okay. Similarly, bx I cap, by j cap, bz a cap. Okay, no problem. Very good. Now we want to get a dot b. We want to get the a dot product. So the symbol of dot existing here, a dot b. Take what it means, just like symbolically, definition wise, this is a mod of a, mod of b, cos theta. Simple thing. Magnitude of the a, magnitude of the b into cos theta. You will tell, sir, why this is coming. No, it is not why. It is just like a definition. It is a definition. We are defining a vector operation, just like we have operated vector addition, vector subtraction. Similarly, special operations we are doing, it is required. It is not that, it is a required. The special operation we are doing, the dot product between the two vectors, and these two vectors is giving after dot product is scalar quantity. Bas. What is the magnitude of the scalar quantity? This much. Magnitude of A, magnitude of B into cos theta. So where the cos theta is going to come, just like see, you can observe this is a vector A, this is a vector B. You can observe there is an angle between them naturally. Two vectors existing, so there definitely there is a chance that they are going to have some angle between them. So that angle, the cos theta. Okay, no problem. Very good. A dot b cos theta, magnitude of the A, magnitude of the B into cos theta is called the dot product. Okay, now see, you can observe from here what is the magnitude of the A. What is the magnitude of the A? Just already we have seen that. Three-dimensionally, if I observe the coefficient of the x, coefficient of the y, coefficient of the z. if I just square it, add it and make it square root, isn't it? You understand, na? Just like see, this one is the cuboid, just like 2-3 class before, 2-3, just like this one. This is the x component, y component, z component. What is the magnitude? X square plus v square plus c square whole root. Huh? The same thing we are going to apply here. We are going to apply here. Mod a, it should be root over of ax square, ay square, az square. Mod b, bx square, by square, bz square. Thus, so we can use it here. Root over of ax square, ay square, az into bx square, by square, bz square into cos theta. So this is a dot b. Therefore, cos theta is equal to a dot b root over of ax square, ay square, az square, bx square, by square, bz square. This is the way we can find this cos theta. But how to find this dot product? How to find this dot product? Actually, result the value of the a dot b. First of all, we have to find na. ठीक ना? Similarly, you can observe that just like if I want to get that a dot b. So first of all, I have to know if I want to just make the dot of the I dot I, what the thing is going to happen? Just I is also, I cap is also unit vector still. So I dot I, what is the formula? Magnitude of the I into magnitude of the I. Magnitude of the I means 1. Magnitude of the I means 1. 1 into 1 into cos. Cos kato? I and I, they are parallel. So cos 0. Cos 0 1. So it is 1. I think you understanding, children, because I dot I means 1 dot 1 into cos 0. 1. Magnitude of the I into magnitude of the I into cos 0, isn't it? So that's 1. But if I is going to make this one I dot j, huh? What is it is coming? Magnitude of the I means 1. Magnitude of the j means 1 into cos 90. Why? Why cos 90? I and j mutually 90 degree. So cos 90 0. 0. I dot k. It is also 0 because I and k mutually perpendicular. Cos 90 0. Similarly, j dot I 0. J dot j is equal to 1. Cos 0 1, isn't it? On 1 into cos 0 means 1. J dot k is equal to 0. Similarly, k dot I 0, k dot j 0, k dot k 1. So only you can observe I dot I, j dot j, k dot k only giving the result 1, others are 0. Simple thing. Okay? There is no confusion. Okay, very good. You can now just we're going to observe this thing like little bit. I'm just placing this one a little bit separately. Now you can just we're going to do this one. A vector dot b. Okay, ax I cap plus ay j cap plus az j cap dot bx I cap by j cap bz j cap. Okay, you can observe ax, that's simply multiplication. This ax bx I dot I mane 1, ax bx complete. Similarly ax by I dot j 0, ax bz I dot k 0, ay bx j dot I 0, but ay by j dot j, that is 1. Similarly j dot k 0. Now with the k, az bx k dot I 0, az by k dot j 0, but az bz k dot k 1. So ultimately that a dot b, the result we have got. A dot b is what? Ax bx plus ay by plus az bz. We got that thing. Now we found already the angle cos theta. We found angle cos theta. Okay. A dot b is what? Ax bx plus ay by plus az bz. So we are just going to put this one, ax bx plus ay by plus az bz, take, divided by root over of ax square plus ay square plus az square into root over of bx square plus by square plus bz square. So this is the angle. This is a method. This is a methodical process through which we can just find, by making the dot product of the two vectors, we can find the angle between the two vectors. This is the angle cos theta. By inversing that cos theta, we can get, first of all, we will get the value of the cos theta. After that, we will find that inverse of the cos theta. We will get the result. We will get the angle. This is the way. This is the procedure through which we can find the angle between the two vectors. Okay, children, I think you understood. Any problem? No problem, isn't it? Very good. Okay, nice. Just like, see, very simple questions are there. Simple questions will be commented. There is no hi-fi things are there. Suppose I'm going to have a vector in 2i cap plus k cap plus 3k cap, okay, and b I cap plus 3j cap plus mk cap. Okay, m is not informed. Okay, question is telling that find the value of the m so that a and b are mutually perpendicular. What is the value of m so that a is perpendicular to b? Children, understanding my point? If a and b are perpendicular, so then what will be? A dot b mane a b cos 90. What is the cos 90? Cos 90 is 0, isn't it? Cos 90 is 0. So this is 0. Like a dot b is a 0 in this situation. So how can I find? So this is the, so a dot b will give 2 into 1, 2 into 1. This is 1, 1 into I, 2 into 1 plus 1 into 3 plus 3 into m, isn't it? 2 into 1 plus 1 into 3 plus 3 into m. This is the result of the dot product. So 0. Take 3 plus 2, 3 plus 2 is 5. 3m plus 5 is equal to 0, তাহলে 3m is equal to minus 5. Therefore, m is equal to minus 5 by 3. Children understanding my point or not? Children understanding my point or not? Understanding, definitely. Simple questions will come from here. Okay, now that suppose I'm going to have a vector like vector a I cap plus j cap plus 2k cap and vector suppose a vector b is equal to 2I cap plus 3j cap plus 2 vectors are there. Okay, 2 vectors are there. Okay, very good. Now find the vector expression of the component of the A along B. Vector expression, vectorical form of the component of the A along B. Are you getting my point? What the question is? Huh? Vectorically express the component of the A along B. I think you understood, isn't it? I think you understood the question. Okay, very good. So just geometrically, how can I see that? Suppose this is a vector A, this is a vector B. Okay, this angle is theta. If I drop a perpendicular, this is what? A cos theta. So this is the component of the A along B. This A cos theta is the component of the A which is going to act along B, isn't it? Simple thing. So what we require that vector expression of this component. Vector expression of this component. Whose component? Component of the A. So since this A cos theta which is going to act along the B, if I want to express in vectorically in the vector form, we require the unit vector along B. So what is the unit vector? B cap. Check. Understanding my point? Unit vector is B cap. Check. And this B cap multiplied by A cos theta is the vectorical expression of the component of the A along B. B cap A cos theta. Simple thing. একদম জলের মতো। ঠিক আছে? So now if I want to get the unit vector along B, so how can I do? Just like we have done this just previously. The vector B by mod of B. ঠিক আছে? Vector B কত? 2I cap plus 3j cap plus k cap divided by mod of the B. What is the mod of the B? 2 square plus 3 square plus 1 square. তাহলে 2 square root over of the 2 square মানে এইটা। তাহলে 3 square plus 1 square, ঠিক আছে? So 2I cap plus 3j cap plus k cap divided by root over of 2 square মানে হচ্ছে 4, 3 square মানে হচ্ছে 9, 1 square মানে তো 1, তাহলে 9 plus 1 10 না, মানে root over of 14। এত বড় তো আমার দরকার নেই। root over 14. This is the B cap. This is a unit vector which is going to act along B. Found it? No problem. Very good. Now what we require? We require A cos theta. We require this length, this length, A cos theta length, because already we found the B cap. We require only this. Okay, no problem. So now just like see, we know A B cos theta is equal to A dot B. A dot B. So what is the A dot B? 1 into 2 plus 1 into 3 plus 2 into 1. Okay, understanding? 1 into 2 plus this 1 into 2 plus 1 into 3 and this 1 into 3 plus 2 into 1, isn't it? So 1 into 2 মানে 2, 3 into 1 মানে 1, 2 plus 3 মানে 5, 5 plus 2 7, তার মানে mod a b cos theta is equal to 7. What we require exactly? We require mod a cos theta. So mod b is already known. Mod b already known, root over 2 square plus 3 square plus 1 square. Yeah. So root over 2 square plus 3 square plus 1 square মানে root over 14. The mod a cos theta is equal to 7 by root over 14 because we are going to put the mod b here. So 7 by root over 14, just whenever I'm going to put, this is revealing a cos theta. So now you can see 7 by root 14 is equal to this much. Just now this expression, the vector expression of the component of the a along b, I'm just writing that thing, 2i cap plus 3j cap plus k cap by root 14. This is the b cap already derived. Now we're going to put that a cos theta, mod a cos theta, that is the 7 by root 14 into 7 by root 14. ঠিক আছে? So what the thing is going to happen here, root 14 মানে শুধু 14, only 14, তাহলে 7 by 14 মানে 2. Therefore we can write like this way, 2i cap plus 3j cap plus k cap divided by 2. This is the actual vector expression of the component of the a along b, মানে b cap a cos theta. That expression is this much, 2i cap plus 3j cap plus k cap divided by 2. Children, I think you're understanding, isn't it? You are going to understand all these things. Okay, any problem? If you still have any kind of problem, you can ask me. You can just verify through our experts in our VidyaNest if you still have any confusion. Okay, if a question is going to give, they're going to give a question like this way, like let's think that if I'm going to have the unit vector of two vectors, two unit vectors are there. If the sum of the two unit vector is also unit vector, sum of two unit vectors is also a unit vector, sum of two unit vector is also a unit vector, then what is the magnitude of their difference? Suppose I'm going to think that a cap b cap, two unit vectors, and a cap plus b cap is equal to also a unit vector of another vector, that's a unit vector c cap. Okay, so c cap. So what do you think is going to happen here? So what is because I'm just going to take the a cap is equal to 1 mod of b cap mod 1 and c cap mod, it is also 1, isn't it? Three vectors, three unit vectors. The addition of the two unit vectors is going to give a vector which is also unit vectors. Okay, so now you can just like see 1 square is equal to 1 square plus 1 square plus 2 into 1 into 1 into cos theta. Okay, so 1 is equal to 2 plus 2 cos theta. Okay, মানে minus 1, 1 minus 2 is minus 1 is equal to 2 cos theta. Cos theta is equal to minus half. Any problem? Therefore, what the result is going to come, theta is equal to 120 degree. Children, understanding my point or not? The question is going to tell that the addition of the two unit vectors is also a unit vector. Therefore, we're going to find that the angle between the two unit vectors is 120 degrees. Just like see, if this is the unit vector, If this is a unit vector, then the resultant, this is also unit vector. Okay. So the length is so on. Each and every one is 1. So they are going to tell that. You have to find that. You have to suppose this is the A cap. This is the B cap. So they are going to tell that. You have to find the A cap minus B cap mod, the magnitude of the difference. What they are going to tell? What they want? They want what is the magnitude of the difference of these two unit vectors. Magnitude of the difference of these two unit vectors. Now see, just if I just want to find the difference, magnitude of the difference. So just like just I'm producing this one. This is the minus B cap, isn't it? Minus B cap. So the angle between them, A cap and B cap, already found 120 degrees. So then A and minus B cap, this angle is going to remain 60 degrees, isn't it? A cap and minus B cap, because we have to find this magnitude, na? A minus B cap, A cap minus B cap, magnitude of that thing. So what is the angle between them? A cap and minus is 60 degree. Since this is 120 degree, I think it is clear to everyone, isn't it? So now if I want to find that magnitude of the difference of A cap and B cap, then what is the magnitude of the A cap? 1. What is the magnitude of the minus B cap? That is also 1. Magnitudically B cap and minus B cap both are same. Already B cap is 1, so minus B cap is also 1, isn't it? তাহলে বলো 1 square মানে A cap minus B cap mod 1 square plus 1 square plus 2 into 1 into 1 cos 60. ঠিক আছে? So 1 square plus 1 square মানে 2 plus 2 cos 60 মানে sin 30, তাই না? তাই তো একদম, মানে half, মানে 2 plus 1 মানে 3, মানে এটা স্কোয়ার অ্যাকচুয়ালি। তাহলে এটা তুমি যেটা করবে, this thing has to be square root here. This is the mod of mod of A cap B cap mod is equal to root 3. So magnitude of the A cap minus B cap is equal to root 3. Okay, children, I think you just are going to, you're understanding these concepts, and this kind of questions can come in either in any exams. You should be familiar with all these things. Okay.